All right. So a Venn diagram can be used to illustrate a conditional statement as well. So let's see if we can make sense out of this and write a conditional statement for these Venn diagrams. So this Venn diagram here, we have colors in the larger circle, and then we have red in there, right? So basically red is a color, right? So we can say if an item is red, then it has color, right? Okay. All right, similarly, the one on the bottom. So we can say, okay, well, so Italian fits inside Romance languages, right? So we can say if a person knows Italian, then they know a Romance language. Then they know a Romance language. All right. So basically, the circle inside, right, becomes your if, or your hypothesis, and the larger circle is your conclusion, right? So if it's in here, right, if it's in here, then it must be in here. All right, let's try to use what we know about conditional statements to actually make some conclusions. So here we have a statement that says all marathoners have stamina, right? So in other words, if a person is a marathoner, then they must have stamina, right? So in other words, if we assume this is true, right? So we say, suppose this is true. So that means if the hypothesis happens, then the conclusion must happen, all right? So like part A, Nick is a marathoner. So if you're a marathoner, then you have stamina. So we can conclude if Nick is a marathoner, Nick must have stamina. Okay. All right. So part B, Heidi has stamina. So the conclusion is true, but does that mean that the hypothesis is true? Not necessarily. And so this, we can't conclude anything. So no conclusion. Okay. So if you know the conclusion, or if you know the conclusion of a conditional statement, you cannot assume that the hypothesis is true. Now, the other way around, if you know the hypothesis of a true conditional, then you can assume that the conclusion is true. All right, part C, Mimi does not have stamina. So let's investigate this for a second. So Mimi does not have stamina. So now we're saying, okay, well, we just negated the conclusion. And so remember that the contrapositive of a conditional statement has the same truth value as the original, right? And the contrapositive of this one would say if if someone did not have stamina, right? I'm just going to shorthand this. If not stamina, then not marathoner, right? Then you couldn't be a marathoner. All right, once again, excuse the shorthand there. But that's what's happening here. Mimi does not have stamina, right? So the hypothesis of the contrapositive is true. And so that means that the conclusion must be true. So that means that Mimi is not a marathoner. Okay, so that's how you can use the contrapositive to make a conclusion. All right, and then part D, Arlo is not a marathoner. So we're negating the hypothesis, and if you negate the hypothesis, that doesn't necessarily mean that the conclusion or the negation of the conclusion is true. Okay, so there's actually no conclusion that you can make with that one, because basically what you're doing is you're resorting to the converse, or excuse me, the inverse, where you're saying if not a marathoner, then they do not have stamina. And remember that doesn't necessarily have the same truth value as the original conditional. Okay, so here there's no conclusion. All right, so we'll practice more with these in class. These are a little bit tricky, but just remember, if you have a true conditional, and you could pick this apart, but this statement. So we assuming it's true. If it is true, then A and C, we can find a conclusion based on those statements, whereas B and D, no conclusion is valid.